Hi guys, welcome back. So in this video and in the next couple of videos, I want to explain how to approach problems in natural language processing. So this methodology that I explain can be applied to almost every natural language processing problem. And I'll try to explain from the basics, all right? So let's just say that I have a data set of sentences, right? Because that's what natural language processing is. You want to convert your natural language, which might be in English or French or Spanish or whatever language it is, to something that the computer can understand, uh, and process it in a manner that gives you good predictions about the sentiment of the language or the conversation, or especially in chatbots, this is used a lot. So let's just take an example. I have let's say take for example I have reviews on an e-commerce platform like Amazon. And the problem I'm trying to solve is that whether the reviews are positive, neutral, or negative in sentiments. All right. So let's say I have a data set of, for simplicity, just three reviews. Okay. The first review is something like the noodles are very tasty and affordable. Okay. The second review is that the noodles are not tasty and affordable. And the third review is, um, let's say something like noodles packet is red in color. Okay, so these are my three reviews. For simplicity, I've only taken three reviews right now. But in a real life data set, these reviews can extend to like 100,000 or million reviews easily. So so the thing is, first off, with NLP, what you have to do is you have to somehow find a way to convert this sentence that you have. The noodles are very tasty and affordable. You have to somehow find a way to convert this sentence to something that machine learning or deep learning models can understand, so that they can process the sentence and try and find out the sentiments or sentiment of this review, right? So you have to find a way to convert this into numbers. Okay. Because, well, machine learning models only understand numbers, they don't understand words. So we have to first find a way to vectorize this. All right. Vectorization will ensure that, I have a vector for each review that is expressing that review in numbers. Okay. So what I have to do is I have to vectorize my reviews to feed them into a model, right? So a vector for each of these reviews will ensure that it's a sequence of numbers in a d-dimensional space that explains the behavior or the characteristic of a particular review, right? So I need to find how to I need to find um, I need to basically find a way to vectorize my review, right? Now, before I can even get to the vectorization, there is something that we need to do in NLP, and not just NLP, in almost all of machine learning and deep learning. And that is called cleaning your data set. Okay. Cleaning your data set, right? The thing is, no, not a lot of university courses stress a lot upon cleaning your data set, but in reality, if you're working at a company, you would spend at least 20 to 30% of your time just cleaning the data set. That's how important cleaning the data set is. Because, machine learning models are basically garbage in, garbage out. If you feed garbage to it, it's going to predict garbage. So we need to clean our data set such that only good and useful information is fed to the machine learning model. So first off, when you clean your data set, the first thing to do is, these are just some techniques or some methods that you follow. These are generally followed and widely accepted. Now, there's no hard and fast rule that you have to do them, but generally in every machine, in every natural language processing problem, you tend to do these steps that I'll now explain. The first step is deduplication. Okay. The thing is, in a data set such as reviews, right? Uh, you might have something like an ice cream. Let's just take, for example, an ice cream. And earlier, there was only one flavor for that ice cream. So everyone wrote a review for that particular ice cream, right? But sometime later, because reviews are generally temporal data, sometime later, that there was another flavor for that particular ice cream that was, put out in the market. So let's say first I had only chocolate ice cream of a particular type, and then later, after some time, let's say 60 or 120 days, vanilla flavor was also sold on the e-commerce website like Amazon. Now, what happens is, what these Amazon and these e-commerce websites tend to do, the people who write reviews for the chocolate flavored ice cream, once the vanilla flavor comes out, those same reviews are also linked to the vanilla flavored ice cream. So you essentially have the same review for two different flavors of ice cream, right? And what that leads to is that it leads to duplicate data. If you if you have a very large data set, duplicated data set might be not very useful for you, because you already have that data, you already have that particular set of reviews for the chocolate ice cream. So you don't need the same set of reviews for the vanilla flavor as well. You just need it once to analyze the sentiments, right? So the first step is deduplication, where you actually analyze the data set, see if your reviews are duplicated for multiple products that are being sold. And if that's the case, if the same review applies to two different products, you would want to remove that review from a particular product. Either one of them, doesn't matter. Especially in problems where I'm trying to find the sentiment of a review. So that is what you call deduplication. You basically remove, duplicate data points or reviews. Okay. The second technique is something called stop word removal. Okay. So now what is a stop word? So if you look at these reviews, review 1, review 2, review 3, now when I'm trying to find the sentiment of a review, let's say review 1, the review 1 is something like, the noodles are very tasty and affordable. The noodles are not tasty and affordable. Noodles packet is red in color. If you take all of these reviews, you would notice that the actual information about the sentiment of the review lies in words like very tasty, affordable, or packet is red in color, something like that, right? Red, packet, color. That is where the information or the sentiment about a review lies. I think you would all agree with me that there is no particular sentiment or information in words like the or and is. These words, the and is, they don't carry any particular information about a review. They basically are called stop words. So stop words is are words like this, the, and, them, they, who, how, what, where, when. All of these words that occur very often in English, in particularly in English, but they don't add any value to the sentiment or the characteristics or the information available in a review, right? These words are called stop words. And so the next step is to remove stop words. Okay, so you generally want to remove your stop words. Remove all stop words. Now, what are the stop words will depend on your on your problem. What words you want to remove will change a little bit from problem to problem. But generally, there's this uh, library, very popular library in machine learning called NLTK. It has a built-in function that removes stop words automatically. So you have to do that. The third step is to convert everything to lowercase. Convert everything to lowercase and remove punctuation like comma. Okay, you have to remove all the punctuation marks like exclamation mark or a full stop, a comma, semicolon, whatever. Again, those don't add a lot of value to a sentiment. I mean, if I put a comma here, the noodles are very tasty and affordable. How is that comma adding any value to um, the sentiment of this review, right? So you want to remove all punctuation marks and everything, and you just want to clean your data. Now, why do you convert everything to lowercase? Is because we want consistent data throughout our entire data set. We don't want some words that are uppercase and some that are lowercase. We don't want that. We want everything that's consistent throughout a data set so the model can learn and understand the characteristics of a data set better. So this is the third step, convert everything to lowercase and remove punctuation, right? This is what you do. The fourth step is to convert, it's basically called stemming. Okay, stemming. Now, what is stemming? I'll explain what stemming is. So let's say that I have a word like tasty or let's not take tasty. Let's take something like um, you know uh, played, playing, playful, right? So look, if you look at these words, played, playing, playful, now all of these words, like all three of these words, just try to convey the same meaning that someone is playing. Maybe the subject of the sentence is playing something, right? And if you observe the English language, if you know the English language, the thing is, all these words stem from one word, which is called play, right? And that's what each one of these words is trying to portray, that the person or the subject in of the sentence is playing something, right? So it doesn't make sense to use three different words in your data set. It makes more sense to find the root word for all of these words and just use that stem. It's called the stemmed word, all right? Just use that word as a replacement for all these three words, okay? So that's what I'm going to do. I'm going to stem all of these words to its root word and I'm going to replace them with that particular word, which in this instance is play, okay? Because all these words have the same meaning. That's all of these words are trying to sorry, all of these words are trying to portray the same thing, the same meaning. So this is called stemming, okay, where you take the word and you convert it to its root word. Now, there are basically two different types of stemmer. That is the Potter stemmer and the snowball stemmer. And both these stemmers are built on different rules of linguistics, all right? So this is a very deep subject in itself, linguistics. And Porter stemmer is the old one, and snowball stemmer is the more new and sophisticated stemmer. This is more widely used in industry, but Porter stemmer is the old one, and it's also very useful. So these are two stemmers that are available in NLTK, and I'm not sure if snowball stemmer is available, but Porter is available. So that is the fourth step. You would stem the words to their root word, okay, or the word from which all these words stem out. The fifth part to cleaning your data set is something called lemmitization, right? So what is lemmatization? Well, lemmatization is basically, let's take for example the sentence. The sentence is goes like, I live in New York. Okay. Now look, I'll explain in the next video how you convert this sentence to a numerical vector. You basically use something called tokenization. Tokenization is just separating each word into its own kind. I basically create a dictionary, a huge dictionary of all the words that are in my corpus, and I try to find all the distinct words that are available in my corpus. So like tokenization is basically separating each word in a sentence. Okay, so tokenization would give me I as one word, then live as one word, in as one word, new as one word, and York as one word. Okay, so what tokenization would do, it would give me new and York as two different words, right? But we know that New York is the name of a city and it's just one word, right? So that's what lemmatization does. Whenever you have words like New York, that will be, and if you try to tokenize the sentence, it would give two different words. What you do is you use lemmatization. Lemmatization ensures that this word would be counted as just one word. New York would be counted as one word and not two words. Okay. So once you lemmatize this and then you tokenize this, tokenization would give you four words and not five after lemmatization. It would give you I, then live, in, and New York. Okay. Otherwise, if you don't lemmatize it, tokenization will give you two different words in your entire dictionary of words. But we don't want New York as separate words. We want it as one word. So we have to lemmatize it. So tokenization would give me all of these four words in my dictionary or from my corpus. Okay. So this is what general natural language processing workflow is about, how you clean your data. And the next few videos, I'll explain how to actually vectorize the data and the different techniques that we use to vectorize the data.